Hello, in this video we want to solve this. The equation of the total cost curve facing a perfectly competitive firm in the short run is TC equals to 50 plus 2Q squared. At what level of output the average cost of production will be minimum? Now, for a perfectly competitive firm, the price is constant. Price of output is constant. This argument is not required for this question. Now, the total cost is 50 plus 2Q squared. 50 is the fixed cost, which is independent of the level of output. Now 2Q squared is the variable cost which depends on the level of output. Now what is the average cost? Average cost denoted by AC is total cost divided by output produced. That is 50 plus 2Q squared by Q. This is 50 by Q plus 2Q squared by Q. Therefore, AC equals to 50 by Q and 2Q squared by Q. This Q and squared get cancelled. Therefore, this is 2Q. Now, we minimize this average cost with respect to output. We minimize AC with respect to Q. Therefore, we do the minimization exercise. First, we do the first order condition. First, we differentiate AC with respect to Q and we equate this thing with 0. This implies if we differentiate AC with respect to Q, that is 50 by Q plus 2Q. 50 is constant and Q 1 by Q, differentiation of 1 by Q is minus 1 by 1 by Q squared. That is 1 by Q is what? Q to the power minus 1. If we differentiate 1 by Q with respect to Q, that means dq of Q to the power minus 1. This minus 1 comes here and then Q to the power minus 1 that is minus 1 Q squared. Minus 1 minus Q squared, that is 1 by minus 1 by Q squared. This is our, and then 2Q. 2Q is plus 2 and Q with respect to, we differentiate Q with respect to Q is 1. This is equals to 0. Therefore, we are getting minus 50 by Q squared plus 2 equals to 0. Minus 50 by Q squared plus 2 equals to 0. Now we further simplify this. dSc by dq equals to 0 implies minus 50 by Q squared plus 2 equals to 0, or 50 by Q squared equals to 2, or 50 by 2 equals to Q squared, or Q equals to, this is becomes 25 equals to 5. Since Q cannot be 0, Q cannot be negative number. Q is 5. Q is 5. Now we check the SOC, second order condition. That is, we second time differentiate AC with respect to Q. d dq of dAC by dq is d of dq is minus 50 by q squared plus 2. Again this minus 2, q to the power minus 2. Therefore this is minus into minus 2, 50 by q cube. This is our 100 by q cube, which is positive. Therefore is second order condition is satisfied. Second order condition is satisfied. Second order condition is satisfied. Now at q equals to 5, at q equals to 5 units, average cost is minimized. AC is minimized. This is the question: at what level of output the average cost of production is minimum? At q equals to 5 units, average cost is minimized. This is the answer of this question. I hope everybody understood the solution of this question. That's it for this video. Thank you.